Trigonometric ratios, quadrants and angles. Question 1. The coordinates of a point on the terminal arm are shown. Determine the exact trigonometric ratios and the angles. Well, here we have a set of videos which will explain you how to find trigonometric ratios and the angle. When I say angles, primary principal angle, okay? It's a principal angle which is measured from positive x axis towards the terminal arm, right? Now, so I have taken points on the terminal arm, and these points will be in quadrant 1, 2, 3 and 4, different quadrants, right? And you'll appreciate how the value of trigonometric ratios change. A couple of things to remind you. One, you should always check your values with the cast rule. Cast rule is that in quadrant 4, like CAST, right? So in quadrant 4, cos is positive. All are positive in quadrant 1, sine in 2 and tan in 3. So, and these are your quadrants, like 1, 2, 3 and 4. Since the given point is on the terminal arm, which terminates in quadrant 2, we have sine value as positive and cosine and tangent will be negative. So there's kind of an observation when you see it. Now to find the trigonometric ratios, we need x, y and r. The length or the radius of the circle, or you can say length of the terminal arm, right? So that is what is a must. So we need to find that. Second, to find the angle, whenever we are saying angle, we want this angle. That is our principal angle, right? From x to this. Now to find this angle, what we do is we really find acute angle. That's the acute angle. Once we find acute angle, then we can take away from 180 degrees the acute angle and get the principal angle theta, right? So we'll write this as theta and that as alpha, correct? So now we'll solve and figure out what are the trigonometric ratios and what is the angle. Since the accuracy is not given here, we'll just assume it to be a whole number, okay? Now, so first step let's do is find out the length of the terminal arm, which happens to be the hypotenuse of a triangle. Now, whenever you make a triangle, drop a perpendicular on the horizontal x-axis. So the triangle you get is this one, correct? So that triangle will help you to find all the trigonometric ratios, correct? Use this triangle. That's foremost. Now, in this triangle, the point P is minus 3, 4. That means x value is minus 3, y is 4, right? Now, we need to find what hypotenuse is. Since we dropped this perpendicular, this is 90 degrees, and that hypotenuse could be found using Pythagorean theorem, right? So we'll write x square plus y square is r square. So we can write r is equals to square root of x square plus y square. Now the points are minus 3 and 4. So this is square of minus 3 plus 4 square. Minus 3 square is 9 and 4 is 16. And that gives me square root of 25, which comes down to 5. So we have hypotenuse or r as 5. Now when we know this, then we can find easily all the trigonometric ratios. So first let's find the primary trigonometric ratios, okay? So the primary trigonometric ratios are sine theta, cosine theta and tan theta. So sine theta is y values. The point is minus 3, 4, right? That's the point. Let me write down the point clearly. Point is minus 3, 4 and hypotenuse will write down radius as equals to 5 units, correct? Now sine theta, and that is our x value and this is the y value, correct? Sine theta is y over r, right? So the y value is 4 and r is 5. So that is the value of sine theta. Cosine theta is x over r. X value is minus 3. So we get minus 3 over 5. So that is the value for cosine theta. As expected, sine is positive, cosine is negative. And tan theta for this particular position will be y over x. So y value is 4, x is minus 3. So 4 over minus 3, which should be written as minus 4 over 3. Right? Now, reciprocal of these ratios are, for sine it is cosecant. So cosecant theta is equals to 5 over 4. Sine and cosecant will be positive in quadrant 2. The rest will be negative. Secant theta is reciprocal of cosine, so we'll get negative of 5 over 3. This one, right? And cotangent theta, cot theta, is reciprocal of tan, so it is minus 3 over 4. So these are our trigonometric ratios. Now, let's try to find the angle, primary principal angle, okay? So the principal angle could be found first by finding the acute angle. So first let's find related acute angle. So for related acute angle, what we can do is, we know tan alpha. Let alpha be the related acute angle. Tan alpha is equal to 4 over 3, right? Y over r, correct? 4 over 3. So alpha is equal to tan inverse of 4 over 3. Correct? So we'll use calculator to find tan inverse of 4 divided by 3, and we get 53.13, which is 53.13. Let's round it to 53 degrees. So related acute angle is 53 degrees. Note, we didn't take any sine. Just consider one triangle like this. Think this triangle is in quadrant 1, right? A congruent triangle here. Think like this, correct? Same angle, right? These will be the same angle, correct? So we are interested in solving this particular triangle and find that related acute angle, okay? 53. Now, the angle theta will now be equals to 180 degrees minus 53 degrees, okay? Which is equal to 10, take away 3 is 7, and 7 is 2, and we get 127 degrees, okay? So that is our principal angle which we are interested in. So theta is equals to, let me write approximately because we rounded it to the whole number, 127 degrees, correct? So that is our solution. So we got all the principal, primary and trigonometric ratios and the principal angle, okay? That's how it is. Now, try to do the other questions first on your own and then watch the video. That is going to help you a lot, right? And you'll gain confidence as we move on, okay? Thank you and all the best.